Good morning. Our project title is Design and Implementation of Flywheel Energy Storage System using Boost Multi-Level Cascade Converter. Our batch number is AB6 and the batchmates are Sharmila, Shalini and Arivalagan. So, we are using two supply here, one from PV array and another is from capacitors. The PV array for testing purpose is given as DC input which is 48 volts. In this phase, our objective is to implement the hardware, and this is the hardware setup. Here we are using three transformers of rating 230 volt to 12 volt transformers. From that transformer, we are getting a 12 volt supply, but the controller unit requires only constant 5 volt input. To make the 12 volt to 5 volt, we are using bridge rectifier and an voltage regulator. In the bridge rectifier unit, we are using diodes IN4007 and voltage regulator which is IC7805. From this, we are getting a constant 5 volt input. The microcontroller we are using here is PIC16F877A, which is a 40 pin microcontroller. The first pin is connected to the input, the last pin is connected to the output, and the center pin is grounded. To the 12th and 13th pin, we have connected a crystal oscillator, and the operating frequency of the crystal oscillator is 10 to 16 megahertz. We are using ceramic capacitors which works as grounding capacitors. We have also used an LED along with a resistor to which the voltage is dropped and given. This LED is to indicate if the controller unit is in on state or off state.
In this unit, we have used 4 IR2110 driver circuits and 8 IRF840 N-channel MOSFET switches. These driver circuits take 12 volts as input supply. The PWM pulse generated by the microcontroller unit is given to the MOSFET switches. These pulses has an amplitude of 5 volts, which is a weak signal for the MOSFET switches. This weak signal is converted into a strong signal, that is 12 volts, with the help of these driver circuits. Out of the 8 MOSFET switches, 4 switches are used for hedge bridge and 4 switches are used for cascading to achieve the multi-level. The output is measured across the load resistor, which can be seen from the DSO. We have obtained a 5-level output voltage with a peak value of 73 volts.
As already mentioned, we have two supplies. One is a PV array supply and another is a capacitor supply. As of now, we have connected the PV array supply and we took the output. Now we are changing the supply to the capacitor supply. So this is the input voltage we are getting, 56 volt, and the output voltage now is 69 volts.